So yeah, kind of zoom in on this for you. So 11.4, are those extra? Oh, those are just the homework's coming around, so the quizzes are coming around. So the 11.4 checkpoint quiz, I think you'll find that you're able to do this if you're able to do the quiz we took last week. You guys know the group quiz we took last week? Yeah. This is very similar to that, right? Here's rectangular coordinates, you change to polar. Here's an equation, you change it to rectangular. And here's rectangular, you change it to polar. And I'll tell you what, while we're looking at this, why don't I write down what are the key formulas you need to know for section 11.4. I mean, if I have x and y coordinates and I want to get r and theta, well, how do you get r? Given one of these points, what's the formula that you're going to use if you want to get r? R squared will have to be the same as what? X squared plus y squared. And so what Tim is saying when he's talking about if you want to find r, right, it's plus or minus the square root of that. So I would say that, yeah, this is one of the key formulas right here. R squared equals x squared plus y squared. It's really the Pythagorean theorem, right? What about for finding theta? What's the key formula for finding theta? There it is. Tangent of theta equals y over x, okay? And again, then you may have to go back and do inverse tangent. And you sometimes have to adjust based on your picture. Actually, there's a quiz question I want to go over. Quiz question, I think it was the fifth problem. I want to go over it with you because I noticed, I don't think anyone got it completely right. And I'll explain why. No, that's not true. There were a couple that did. But for the most part, it eluded us. So I'm going to talk about this a little bit. And then what about the other way? What if you have r and theta and you want to change to x and y? Well, there's two formulas that we have, right? What does x equal? R cosine theta, and y equals r sine theta. Okay, so we've worked with those a lot in this class, so that should be okay. All right. So I think those are the basic formulas you need for 11.4. Now, when you look at the checkpoint quiz for 11.5, and this is on the back, a couple things. First of all, people told me they did not like this homework assignment. The problems like number 1 here, A through D, they didn't like it. It's hard to do by hand. It's easy to do on your calculator, right? And you're going to have the calculator for the exam. So I'm not sure, honestly, how many of these I'm going to be asking because it doesn't do me a whole lot of good, nor you a whole lot of good. However, I would ask a question like number 2. Find the points of intersection, okay? And here, it is helpful to graph the two curves on your calculator so you can see the solutions. But then you want to do algebra to come up with the solutions, okay? So I would say on checkpoint quiz 11.5, don't worry about that so much, but do worry about question 2, okay? Now again, we skipped 11.6. For 11.7, I would concentrate on question 1, again, because this is the stuff we did. Question 2, I didn't really get to yet. Maybe we'll talk a little bit about it today, but not so much. Okay, I would concentrate on question 1 when you're getting ready for the exam. Now that's it, though. That's the last checkpoint quiz that I have for you, or that was published. And so I'm going to have to tell you that 11.8 and 11.9, you're going to have to rely on what you did on the homework. Okay, you can always pick some extra problems if you want. But again, you have to know how to do vectors. You have to know how to find their length. But You don't need to do anything with projection, okay? So that's what I would say. Do you guys have any questions about what's on the exam? So it's time to just start reviewing a little bit, huh? Do you guys have the quiz that I just passed back, the group quiz? All right, let's go over one more question from there. Oh, you guys didn't get it? Where's the stack of quizzes? Oh, here you go. Find them. They should be alphabetical, or they were at one point. Although I see Kelsey's on top now, so I don't know. So number 5 says you want to convert the point from rectangular coordinates into polar coordinates. Okay. And what I always tell you guys is, hey, let's draw a picture. Okay. On the exam, you guys draw pictures. You know that I love giving partial credit. Okay. What quadrant are we going to be in here for question 5?
3.
We're going to be in the third quadrant, right?
Yeah.
So -3, -4. So we know we're down here in this third quadrant, right? Here's -3, here's -4. It's down here somewhere. And now we want to convert to polar coordinates. And so what most people did was they said, well, first I'm going to find r. Right? I mean, if you know that this is 3 and you know that this is 4, right away some people said, oh, that's 5, right? But even if you don't know that, r squared is 3 squared plus 4 squared. This is not hard. It's the next part that got people. But again, I put 5. But algebraically, what do I really have to put here? Plus or minus 5, right? And then I'll have to decide which one I need. I mean, that's an algebra step. If you take the square root, you need a plus or a minus. But in geometry class, right, we would just say, hey, it's 5. That's the distance r. But we know that sometimes we prefer to use the negative. So now the other equation that you guys already mentioned to me is that we know that what we do is we take the tangent of theta is equal to y over x. And so in particular, well, let me draw theta so you know what I'm talking about. Theta is going to be this rotation, let's say, right? If I use theta as that rotation, then I can use r to be +5, right? So I guess I could write tangent of theta equals, what would I write? Well, I guess it's going to be 4/3, right? Now let me show you what a lot of people did then. A lot of people said, well, I know. We'll let theta be the inverse tangent of 4/3. But we have a problem here. Can't do that. It's not. What do you mean it's not in the range? You're right. What's the range of the inverse tangent?
Negative pi over 2 to pi over 2.
Negative pi over 2 to pi over 2. So we know when we do that, we're going to be somewhere between negative pi over 2 and pi over 2. So see, if you do that, this isn't theta anymore, right? By the way, do you think I'm going to end up in quadrant? I mean, what quadrants are these? These are quadrants 1 and 4, right? But we're trying to end up in quadrant 3. See, if you just type in inverse tangent of 4/3 in your calculator, and actually I better check. I don't know if I'm in degree mode or radian mode. Let me check. So I'll click on the mode. I'm in degree mode, okay? Which is fine. Let's work in degrees. So if I type in inverse tangent of 4/3, I'm going to get a degree measure of 53 degrees. So what quadrant are we in?
1.
Quadrant 1, right? Now, what you really just computed on the picture is you computed, if this were a 3 and that were a 4, you computed that this angle is 53 degrees right here. Does that make sense to people? Or if you were doing radians, right? Here, I could do the same thing in radians. I'll change to radians. Because usually when we use polar coordinates, we like radians. So let me do the same thing. Second enter. So 0.927 radians, right? So my theta here is 0.927 approximately. But if I want to get the right answer, what else do I have to do? Take that and add what to it? If you add pi to this, because we know pi radians is the same as 180 degrees, now you'll get theta. Do you see that? That's one way to do it. There was another way that some students got it. Some students said, well, look, I have 0.927 radians, which is about 53 degrees, but I see I'm pointed the wrong way, so I'll keep that angle. But then what will I do? Use -5. All right? So let me give you two possible answers that are both good. First of all, let me add pi to this just to see what it is. So if I add pi to the answer that I just got, I'm at 4.06, okay? So one possible answer, polar coordinates, remember, are supposed to be r comma theta. Some people wrote 5 comma and then, something like inverse tangent of 4/3 plus pi. That's one way to do it. Another possible answer would be -5 comma inverse tangent of 4/3. Okay, and if you went ahead and computed the degrees or the radians, that's on the calculator. But these were more challenging than most of the exercises. For number 4, not so bad, because what quadrant do you end up in? Well, let's see. You end up over here, 4, -4. You end up over here, right? And if you're in quadrant 4, you're in the range of the arctan, and it works out okay. So that one works out a little nicer. Okay? So I think that's probably enough on the quiz. All right, so we're going to try and go through some of these exercises. And I guess my question to you guys is, where would you like me to start? Do you want to see 8 or 16? Let me ask that. There's multiple parts for these things. Should I move on? Polar coordinates last time after the quiz. So let's try it. Number 8. They give me z equals -3 minus 3i. I'm going to graph it. When you graph complex numbers, we're saying we took that real imaginary line, we took that imaginary number line, we put them together, right? And so one of the things that the book asks for is, what's the real part of z? Well, this is kind of a dumb one. Actually, this is like the worst test question you could ask someone, because they're both -3. You would have no idea, right, if they know what they're talking about or not, right? It's a bad test question. I wouldn't know if you know which is which. I'm going to assume you do. Okay? So if we graph it, it means on the real number line, the first -3 says, hey, let's go left 3. And the second -3 says, hey, let's go down 3. And so this is the point, z equals -3 minus 3i. And so the first two questions just say, hey, can you find basically the coordinates on the plane, on this complex plane? Now let's see what else the directions ask me to do. Oh, next they put this absolute value of z. So what does that tell me to do? what am I finding here? The book calls that the modulus of z. But I told you guys it's the same as like the magnitude of a vector. We're trying to figure out how far away is z from where? From the origin, right? So what we're really doing is the same thing we were doing just a minute ago when we found r. We're trying to find that green segment right there. Does that make sense? So do you guys know how to do that? Okay, so that's no problem. I'll do it very quickly then. It's just, again, the Pythagorean theorem, right? So we know we're going to take -3 squared, the real part squared. We're also going to square the imaginary part. We're going to take the square root. And here, because it says absolute value, I want positive. Right? We know absolute values are positive. The modulus is going to be positive. All right, so we get the square root of 9 plus 9, which is the square root of 18, which is square root of 9 times square root of 2, which is 3 radical 2, which you can't see because I took it off the map, but that's where it is. Okay. So that's the modulus of z. Okay? And so now the next thing they ask me for, they say arg z, but then they say arg z. All right? The argument. What the argument is the angle. It's the angle in my picture. It's taking the place of theta, right? And so I guess the difference is that arg z, there are no restrictions on theta. But if I say capital arg, what I'm telling you is that I want theta to be between what and what? Negative pi and pi, that's right. Okay, and I think this is a strict one here. But basically, we want to be able to get any point we can on the plane. And we know that when you do polar coordinates, there's lots of different thetas that work. I showed that already in the last problem. But we're saying that we want to be something between negative pi and pi. So as you look at this, right, do you think I'm going to be closer to negative pi or closer to pi when I do the capital A argument? I mean, I guess I should ask this. Do you think I want a positive angle or a negative angle?
Negative.
I want a negative angle. See, negative pi would be rotating this way to this side. Positive pi, of course, would be rotating this way and getting to pi. But negative is where I want to go here, because if I go the other way, I'll actually be greater than pi. So that is the angle that I want for capital arg z. That's the angle I want right there. And so I know that eventually my angle is going to be negative, even if at first maybe I don't get it that way. All right? So we need to come up with the angle, the correct angle. And I hate to say it, but I actually can tell, just because of my unit circle, I already know what the answer is. You probably do too, if you think about it. Here's what I mean by that. Let's say I just rotated until I hit the imaginary axis. How far have I gone by the time I get to this black line right here? Yeah, negative pi over 2. Negative 90 degrees, right? And then when I go to the green line, from the black line to the green line, how much farther have I rotated?
Pi over 4.
Another, negative pi over 4. Negative 45 degrees. So I can tell you already what I think the argument of z is, okay? Just by reasoning that way, I have, negative pi over 2 plus another negative pi over 4. I have negative 3 pi over 4. That's what it's going to be. The problem is, though, what happens if you get an angle where you don't quite see that? Or maybe this one you didn't quite see that. All right? How? Give me a procedure, Paul. Tell me how to do every one of these problems. Okay, well, let's see. It's just like what I just did with polar coordinates. I know that to get the modulus, I do x squared plus y squared. To get an angle, what's the key equation? Again, it had to do with the tangent. Tangent theta equals what?
Y over X.
Y over x. Now, of course, in our problem, this y is really going to be the imaginary part of z, and the x is going to be the real part of z, because that's what happens when you graph complex numbers. Okay? So when I go ahead and do this now, I might say something like the tangent of theta is, well, -3 over -3. Oh, wow. I get the tangent of theta equals 1. Right? But if you do that, that's fine. Tangent of theta equals 1. But what people sometimes say they think they should do next is, well, let's take the inverse tangent. Again, we have a problem. If I take the inverse tangent, what quadrant is my answer going to be in? Talk to each other about that for a minute, and also talk about how we're going to fix the problem. Okay? So talk to someone near you about that for a minute. There's some nice things happening here. People said, okay, inverse tangent of 1. I saw some people actually type in the calculator, so I'll catch up to you. Here I go. I'm going to type inverse tangent of 1. And then some of you actually already figured out what quadrant are we going to end up in. It's either quadrant 1 or 4. Which one's going to be? It has to be 1 because it's positive, right? So there I am in quadrant 1. What the heck is that? That's a certain number of radians, right? I guess what I could do is divide by pi, and maybe I'll actually recognize it. Yes, I do. What is that? That's 1/4 pi, right? So what I just figured out is that when you do the inverse tangent of 1, you get pi over 4. So theta would be this angle, right? There's my theta, and it's pi over 4. But see, we don't want that. We want the blue angle. The blue angle is argument of z. So how do I get the blue angle? Well, what you do is you say the argument of z will equal, well, pi over 4. But then what do I want to do, guys? I want to go all the way back over here, right? And so I'm going to say minus what? Pi. Does that make sense to people?
What if you added pi to get there? Is that illegal?
Well, we'll do that next, okay? What if you added pi? Then you'd be going this way. But let me see what would happen. Let me finish this. If I do pi over 4 minus, how are you going to write pi? Let's write it as 4 pi over 4. And so what do you get? -3 pi over 4. Is that the answer? Yes. So let me ask you, Justin. I'm going to turn the question back at you. What would have happened if I added pi? If I add pi, I add 4 pi over 4, what would we have gotten? 5 pi over 4. Would that be okay?
Yes.
It'd be okay if we have a little arg question. Why not big arg?
Because it's past pi.
Then you're more than pi. You see, the whole point about big argument is that we want to have like a unique answer, a unique representation of the complex number. And if you're allowed any angle you want, we know there's infinitely many answers. So this way I restrict it and I say, well, look, I won't rotate more than 180 degrees either direction, and that way I can represent each number in a unique way. Okay? So that's why I want to subtract, and that's why I want to be very careful when I draw my picture. Does that make sense? Jordan, you asked the question originally. How we doing? I mean, you saw how I did it this way, right? I mean, I took the inverse tangent, and then I realized I have to subtract pi, but you want the quick way. I don't blame you. How did I do it? Well, I just started rotating. Okay, guys, let me kind of go through it in slow motion one more time. Here, I'm rotating this much until I get to what's really the y-axis, right? How far did we rotate so far? How far? Pi over 2, is it positive or negative? So far, it was negative pi over 2, right? And then I realized, look, this is at negative 3, negative 3. That's another 45 degrees. That's another negative pi over 4. And that's really what the fast way then to get negative 3. Do you see it? Negative 2 pi over 4 plus another negative pi over 4 is negative 3 pi over 4. Get that? Okay. That's good. So there's one thing they didn't ask in problem 8 that if I were writing the book, I probably would. So let's draw the picture over again a little smaller. Here's the real axis. Here's the imaginary axis. Here's the point, let's say negative 3, negative 3, right? I mean, really, that's what it is. I know it's negative 3 minus 3i. But another way to write it now, what we learned, is that we can write it as 3 radical 2, because that's my modulus, times, and there's a big parentheses here, cosine. What am I going to take the cosine of? Well, that angle we just found. Negative 3 pi over 4 plus I sine negative 3 pi over 4. And again, this is what the book calls the polar form of the complex number. Again, when we do the polar form, if your complex number is called z, what you put here is the modulus of z, and then the argument is the angle. And this is where the book has an abbreviation. The book says, all right, we can write it that way, but from now on we're going to write 3 radical 2, and the abbreviation they use is cis. And then you just put the angle here, negative 3 pi over 4. Okay, so that's the book's abbreviation. Okay? But all you really need to know, I guess, is that, well, what's going on here is this is the modulus, that's like my r, and this is the argument, that's like my theta. Okay? And so in the next section of homework, what they ask is, hey guys, let me give you the polar form, and the question is, can you go backwards? Can you go backwards and tell me what the complex number was? So let's see, I could do 24 or 32 or 40. Do you guys have a problem you want to see out of those you were working on? 24 is fine? Okay. Let's try 24. So he writes z equals 3 cis pi over 2. Okay? And so that's in polar form. And we want to write what the complex number looks like. Again, this is shorthand. What it really means is 3 times cosine of pi over 2 plus I sine of pi over 2. But he just writes it with the shorthand, cis. Because all you're really going to do is you're going to plot in polar coordinates, right? I think of this as being my r, and I think of this as being my theta. And the only difference between what I've done before with polar coordinates and now is I'm going to call this thing the real axis, and I'm going to call this thing the imaginary axis. Okay? So what I'd like to do is I'm going to pause, and I'd like you to work with someone near you and see, can you plot the point that has this r and that theta? And remember, you want to look at theta first. Okay? I'll pause now. See if you can. Hey, where's pi over 2 aiming at? Show me. 90-degree angle, straight up, right? So I rotate this much, and then r is, we said, 3. So I'm going to be up here. That's the point, right? Right there. That's my z. That's my z. What I'd really like to do now are give its, well, really, it's x and y coordinates, right? So what do you think it's going to be? X is 0 and y is? So we would write 0 minus 3i. If you just want to write z as negative 3i, you got it. That's the complex number. Because remember, we put the real part as my x-coordinate and the imaginary part as my y-coordinate. Now, if you don't like that, say you don't like how I just did that, there's another way to do it. You say, hey, I'm going to distribute the 3. So what I get is 3 cosine of pi over 2 plus 3i sine of pi over 2. What's the cosine of pi over 2? We know that from the unit circle and from all our days doing this. That's 0. So we get 3 times 0 plus, well, let me write the I in front, and let me write 3. And then what's the sine of pi over 2? 1. So do you see you're going to get 0 plus, you're going to get, well, 3 times I. Why did I say negative? Why the heck did I just say negative? I have no idea. That's plus. So the answer is z equals 3i. Negative 3i would be aiming downward. You guys follow? Okay. Should we do any others? Okay, guys. So problem 29 was requested, and this is from section 11.5. And so one of the first things I'm going to do is just take out the graphing calculator and try and figure out where these things intersect that way. So again, if I'm going to do 29 here, right, I want to plot in the polar mode. So I'm going to press mode and go down here. See where it says function? We want to change that. If I go to the right, PAR, by the way, we're going to use that next Monday, parametric. If I go to the next to the right, that's polar. So I'll press enter. And now, when I press y equals, it's not going to say y anymore. What's it going to say? R equals, right? So we can type in R. Let me do R equals 2 just for a minute. This one should be obvious, right? If you graph all the points whose radius is 2, what's it look like?
Circle.
Yeah, a circle with radius 2, right? Now, let me zoom in maybe. Or no, let me do this. Let me hit zoom square so it actually looks like a circle. Well, that's choice 5. Now it's like real graph paper. Maybe I'll zoom in a minute too. Yeah, let me zoom in. Okay, so there's my circle. Now, I still have to graph r equals 4 cosine of 2 theta. So I'll press y equals, but again, it's r equals. And so let me type in 4 cosine of 2 theta. Enter. Graph. Oh, beautiful. That's one of those roses, right? When you start changing the angle by putting a 2 in front of it, or that gives you a certain number of petals, in a sense, to your rose. Okay, so we're supposed to find all the places this intersects. Okay, how many solutions does it look like we're going to get? 8. I'm counting 2 in each quadrant. You guys see that? Okay. So how the heck do you find them algebraically? Well, let's try. And this is going to go back to reviewing stuff from last exam, actually. Okay? So in terms of getting ready for the final, this is not a bad thing. Let's see. So the equations are r equals 2, and what's the other one? R equals 4 cosine of 2 theta. So what I can do is I can substitute, right? This r is equal to 2. Put that in for that r. So I get 2 equals 4 cosine of 2 theta. And so moving on, if I divide both sides by 4, I get the cosine of 2 theta is equal to 1/2. Right? Now, here we go. The cosine of 2 theta equals 1/2. This is where last time what I did, I remember we would replace the 2 theta with some other variable, right? So I might instead say, how about we say cosine of alpha is 1/2? Okay? So again, what I'm doing is I'm letting alpha be my 2 theta. And now I'm going to figure out, well, what could alpha be? So let's see. What are some different values? I got to think about my unit circle, right? What are some different values for alpha that work? Pi over
6.
What is it? Pi over 6 or pi over 3?
Pi over 3.
Pi over 3, right? Or
5 over 3.
5 pi over 3 would work? Sure. And remember, there's a lot more answers, right? You can always add 2 pi k to get more answers. And are we going to want to do that? Well, yeah. We definitely want to do that because we know we want 8 answers altogether. Okay? That's going to be a lot. This is where graphing can help you because it gives you an idea of, oh, how many answers am I looking for? Okay. So let's see what we're going to do next. Well, let's replace the alpha with what we had before. We have 2 theta is equal to pi over 3 plus 2 pi k, or something like that. And so if you want theta, what do? And you get, instead of pi over 3, we're going to have pi over 6. And this is kind of cool too. If I divide this by 2, I get plus what? Pi k. Right? Pi over 6 plus pi k. And so you can throw different things in for theta then. That should work. Over here, I guess I also have 2 theta is equal to 5 pi over 6 plus, well, 5 pi over 3 plus 2 pi k. So theta is equal to 5 pi over 6 plus pi k. Okay? And so now I want to start coming up with some angles that'll give me points of intersection. And I guess so far I see 2 of them. I see pi over 6, and I see 5 pi over 6. And now I'm wondering what other ones would work. Well, if you add pi to pi over 6, what do you get? 7 pi over 6. That'll work. What happens if you add pi to 5 pi over 6? 6 pi over 6 plus 5 pi over 6 is 11 pi over 6. But that's still only 4, not 8 yet. The picture on the screen helped me get it. Maybe it'll help you get it. Okay? Here's the key. Wow, that's very cool. I have to finish graphing and zoom in. Ready, guys? We're going to zoom in, and I'm going to press enter to pause partway through. We are in mid-motion of graphing 4 cosine of 2 theta. You guys with me? All right. So far, right at this point, we started with r equaling 0. It was aiming straight to the right, and it started to graph the rows. Is my radius positive or negative at this point? Positive. Still positive. Actually, we know what it is there. It's, well, we can figure it out. Still positive, still positive, still positive. There it was 2, because that was on the circle r equals 2. Hey, when I get to the origin, what's the radius?
0.
Now the radius is 0. Once I get over here, what's the radius? Positive or negative?
Negative.
Isn't it negative? So if you want to know why we didn't see this solution, it's because what's the radius right there? Negative 2. Okay? And there, and there, and there. In other words, we're not going to find any of these solutions by letting r equal 2.
Wait, how do you determine that the radius is like negative or whatever?
It has to do with, here it's positive, as my little gun rotates, eventually we get r equals 0. When we get to pi over 3, 5 or 6. Hey guys, is my clock slow again?
Yeah, like
I got 3 minutes, right? I want to use them. I think this could help you. Hey, so let me just finish up here. So to explain it, the issue really had everything to do with r equals 2. It is what they gave me. But it's interesting because r equals 2 also is the same equation as r equals negative 2. If you graphed r equals negative 2, what would it look like? It'd be a circle. It's just, the only difference would be this. Here, let's go to the y equals screen and try it. Let me clear out all this stuff. And let me just type in negative 2. The only difference is, where's the graph going to start graphing? On the left. Did you see how it started on the left? Because it was aiming backwards. And so really, if you want to get all the solutions, you play the exact same game we just did with r equals 2, but you try it again with negative 2. And so you get negative 1/2, and that would get you the other 4 solutions. Because when does the cosine equal negative 1/2? Well, again, you can work it out. It would be the other 4 solutions. Okay? Very tricky. I'm glad you asked that one, Justin. That was nice.
Are you still going to keep that off the top?
We'll keep that kind off the test.